Not YouTube yet. Did I like this? I'm cutting it.
Now start to begin because connection.
This math grad always sending one.
Thank you for the 19.
I'm about posting the YouTube link. So those that have not joined will be able to join.
There's no space, so let's get it back. I think you got window. Sorry. I guess my imaginations. Imagination. I don't get many. I don't know.
Mute yourself.
Wish. And
Your mic is muted.
Now, have you gotten the YouTube link?
Yes.
Hello.
yes, ma'am. We've gotten the
Yes, ma, they
YouTube
see
link.
me this link, ma.
Okay. Yeah, so we can start now. This is thanks. This is an MTH 101. It's a course that run across almost all departments. Okay. We are about 10 lecturers that will be taking this course. And I'm to take this very topic, which we call real numbers. I know you don't know me because you are new. I'm Dr. Adetunji from mathematics. So today we are going to be looking at real numbers. Can you hear me?
Yes,
Yes,
ma.
ma'am.
Please just pay attention and listen. At the end of the day, you ask your questions so that we can cover up time. So, our learning objectives. We want to see that at the end of this session, or at the end of this lesson, we'll be able to solve linear equations and inequalities using the properties of real numbers. We'll also be able to solve absolute value equations and inequalities and write their solutions in interval forms. We'll be able to perform basic arithmetic operations on polynomials, rational expressions, and radical expressions, and also be able to solve exponentials and logarithms that can be transformed into linear equations. Our topic is real numbers. What are real numbers? Most times, when we define real numbers, we said real numbers are the rational numbers and the rational and the irrational numbers all put together will make up what we call the real numbers. Now, let's take it step by step. We have the set of natural numbers, which we give by n to be equal to 1, 2, 3. We call these natural numbers. We also call them what? Whole numbers. And the natural numbers, you start counting from 1, 2, 3, down to infinity. Then we have the set of integers. We have the positive integers and we have the negative integers and 0. So our integers comes in from negative infinity down to what? Positive infinity. We have the set of rational numbers. The rational numbers are P over Q such that our PQ and Z and Q is not equal to 0. Whenever our Q is equal to 0, we have the number to be what? Undefined. So if we have P over Q such that our Q is not equal to 0, then we have the number which we call the rational numbers. We also have the set of irrational numbers. The irrational numbers are x in R such that x does not belong to Q. X in R such that our x does not belong to Q. All other numbers in the rational numbers except those that belongs to what? The irrational. Okay, then this moves us down to what our target in the set of real numbers. The set of real numbers, which comprises of the set of real numbers, which comprises of the rational numbers and irrational numbers. From the chart there, we have the rational numbers being drawn with a blue circle. The irrational numbers, that's the fractions. When we have P over Q, we have the fractions being drawn with what? A blue circle. These fractions will say the set of the set of integers are what? They are subsets of the rational numbers. The set of natural numbers are also subsets of the integers, which are subsets of what? The rational numbers. Every other number outside that blue circle is what we call the irrational numbers. So that's why we said the rational numbers plus the irrational numbers gives us what we call our real numbers. Let's continue. So this takes us to properties of real numbers. We all know what real numbers are now. What are the properties which these numbers satisfy? The following properties are satisfied. We have what we call the closure property. This property says for all A plus B in R and AB in R, or for all real numbers AB in R, we have A plus B in R, and we also have AB in R. Am I communicating?
I don't understand.
You don't understand.
We don't understand, ma.
I know you will
I
not
don't understand.
understand.
ma.
We don't understand, ma.
We don't understand, ma.
Let's
You guys stop
continue.
saying
Please
we say
listen.
I.
Now, the
Ele-
closure property says for all AB, our AB are just numbers in R. R, please keep quiet. Our AB are numbers in R. Our R is the set of all real numbers. R is the set of all real numbers. Now you are picking elements from R. A is an element, B is also an element. Now, they are not telling you that for all elements A, B in R, you must have A plus B in R. And also, you must have A times B in R. That's what the first property says, which is the closure property. The second property is the property of commutativity. And this says that for all real numbers AB in R, we have A plus B equal to B plus A. We have A plus B equal to B plus A. And we also have AB equal to BA. We have the associativity property that says for all real numbers A, B, C, we have A plus B plus C to be equal to A plus B plus C. That's associativity under addition. You now also have associativity under multiplication. Identity. The identity law says if you have a unique number 0 such that A plus 0 equal to A for all A in R, there is also a unique number 1 such that A times 1 equal to A for all A in R. This implies that our identity under addition, when we added, the identity under addition is what? 0. And the identity under multiplication is 1. Okay? It moves towards the inverse property. The inverse property says for all A in R, any element in R, there's a real number minus A also in R, such that by the time you add minus A and A, you will get your identity, which is the identity. So therefore, we now say our minus A becomes what? Our what? Inverse. Now, for any non-zero number A, there's a real number A inverse or 1 over A such that A times 1 over A, which is the A inverse, is equal to 1, which is our what? Identity. Then the last law is our distributive law. A into bracket B plus C equal to AB plus AC for any real number A, B, C. The real numbers all satisfies all this property, the closure property, commutativity, associativity, identity, inverse, and distributive property. You can always show that these real numbers, pick any two real numbers, you can show using the condition of the property given to you, what the property says, using this to show that those properties are actually what satisfied. We have some other operations that the real numbers satisfy. We have the operations of subtraction. We have the operations of addition, of division. We have the exponents operation. The operation of subtraction is defined A minus B equal to A plus minus B. The operation of division will defined by A over B, which is A times 1 over B, for B not equal to 0. And we have the exponents. A to power n is the same thing as A times A n times, where n is in n. Okay, so we have operations of fractions. The real numbers also satisfy the operations of fractions. What is a fraction? A fraction is a quotient of two numbers. What is the quotient? Division. Okay, let A, B, C, and D be real numbers such that B and D are not equal to 0. We have A over B plus B over D to give us the same thing as what? AD plus BC over BD. All these are easy to determine. You have seen all these operations right from your primary school, where you take out the operations of addition,
Sorry, ma'am.
within fractions, you use the operations of addition, of subtraction, in between fractions, multiplication between fractions. So all these are elementaries, and we can all understand this very well. I hope so. Yeah.
Sorry, ma'am. Sorry, ma'am. I have a question.
Please hold
In the
on.
multiplication, ma'am. You
Yeah.
said A over B
dot C.
Times.
multiplication. Ma'am. You said A over B times C over
Okay.
D. But you're putting
Okay.
A B plus
That's
C over BD. Is it meant to be that, or it is meant to be AC over BD?
yeah, it's supposed to be AC over B. That's a typo error. So you can always correct that.
All right, thank you.
Is that good? So we can continue.
Yes, ma'am.
Okay.
Yes, ma'am.
A mathematical expression. Remember, we are dealing with real numbers. The properties, what they satisfy, and how we can make use of real numbers. Now, a mathematical expression, we say it's a combination of numbers and operations. Example, if I have 18 minus 3 times 8 divided by 6 plus 2 over 3 into 1 minus 4 square is an expression. That's an expression using what? Numbers. All those numbers you see, are they not real numbers? Yes, they are what? Real numbers. We call it what? A mathematical expression. Now, we look at an algebraic expression as a collection of constants and variables joined together by what? Algebraic expressions or operations. So we have 2x plus 1. 2x plus 1 is an algebraic expression. We have a constant, which is 2, with an algebraic expression x joined together. So when you have 2x plus 1, you say you have an algebraic expression. Operations in mathematical expression must be evaluated in a systematic order, and we use the acronym PEMDAS. We deal with parentheses, the exponents, multiplication and division, and addition and subtraction. We look at this example. How do we solve, or how do we deal with this mathematical expression, this? So we look at the parentheses, the exponents, of course, our exponent, which is this. We look at the exponents, then multiplication and division, and addition and subtraction. We look at our multiplication. So we have 18 minus 3 times 8, 5, and 3 times 5 across is 15, divided by 6 plus 2 over 5 minus 15. You know how that minus 15 is coming? 1 minus 4 square. Our first square, 4 times 4 is 16. Minus 16 plus 1, you have minus 15. So we have dealt with what? The exponents there. So you have 18 minus 3 times 5 divided by 6 minus 6. This will give you 18 minus 3 times 5 minus 6, which is 19 over 2. Okay,
Sorry, ma'am. I can't
these are 2
understand
over
that.
5. Our 2 over 5 is missing here. We have 3 times 5. 3 times 5 divided by 6 plus 2 over 5 into 1 minus 4 squared. So we have 2 over 5 minus 15. So here will be 1, here will be 3. So we have minus 6 here. I have minus 6 there, plus 6 divided by 3 times 5 is 15. 18 minus 15 will give us what? 3. So we have 18 minus, supposed to be 18. What we are supposed to have there is 18 minus 3 times 5 is 15. 15 divided by
They follow the
6 minus, yeah, they
they
follow the
follow the
pendants.
of, so it is multiplication then division.
Yeah, you
That
do
is-
your multiplication before division.
Are you correcting or lecturer?
Yeah, we are doing the multiplication before the division. Now, what is the multiplication? The multiplication is, we have 18 minus 3 times 5.
multiplication is 3 times 5. That's minus 15. They
Minus
divided it by
15.
6.
Yeah.
So they divided it by 6. That was how they got
So
the
there
5
5
over
over
6.
2. So
Yes.
we have
We have
minus 6
18.
there.
Okay. So that is how
So
they have
now you now
18
do your
minus 5 over
subtraction.
2. Yes.
When
That is
you
how.
do your subtraction and look for your LCM, you get what? 19 over 2. Are we good?
No, no, ma.
Yes, ma'am.
Yes, ma'am. We are good now.
Okay, so let's look at our linear equations. An equation is a mathematical statement indicating that two expressions are equal. Now, the value that makes the equation true are called what? The solution. A linear equation in one variable is of the form ax plus b equal to 0, where our a and b are in arrow. They are what? Constants in arrow, with a not equal to 0. Now, here are some steps to solve an equation. We have add, subtract, multiply, or divide by a number or an expression as long as the same is done to both sides of the equal sign. Apply distributivity if need to be, then isolate the variable on one side. Now, this is a linear equation. 2x plus 5 equal to minus 7 in one variable. A linear equation in what? One variable. So how do we solve it? We have 2x plus 5 equal to minus 7. We minus 5, we subtract 5 from both sides. We'll have 2x equal to what? Minus 12. So we divide both sides by half. We divide both sides by 2. We have x to be equal to what? Minus 6. Okay. We'll solve the second one in the same manner. Solving rational equations. We have rational equations. We have x over 2 over x minus 3 over 2 equal to 7 over 3x. How do we solve this rational equation? Here are some hints which we use to solve the two equations. We have a over b equal to c over d if and only if our AD equal to what? BC. So now the solution to that equation, 2 over x minus 3 over 2 equals 7 over 3x. So yeah, what we do, we add up 3 over 2 to both sides, and we also subtract 7 over 3x from both sides. We'll have 2 over x minus 7 over 3x equal to half. Why? We are trying to bring out those ones with x to one side so that we can solve it easily. So we have 6 over 3x minus 7 over 3x equal, and this will give us, by the time we solve, we'll have x to be equal to minus 2 over 9. Okay, so
Sorry,
we
ma'am.
have seen, yeah, I can hear you.
Sorry, ma'am. I want to ask a question.
So
Is it
now I can hear you.
compulsory to solve it in that way that you showed? Is it compulsory to solve it in that way you showed earlier? Is there no other way we can use to solve it?
The other ways you can
Adding
use to
the
solve
fraction
it,
to that
we
side
are
and
only
minusing the 2
trying,
over.
what we are trying to do here. Are you hearing me? Are you hearing me?
I'm listening, ma'am.
Yeah, what we are trying to do here is to show various ways or various things we can use our real numbers to do. You understand? Various
Okay.
things we can use the real numbers
Yes,
to
ma'am.
do. Not that there's no other method to solve it. Of course there is. You understand?
Okay.
So the
All right.
target is, okay,
Yes, ma'am.
I can use my real numbers to do exponentials. I can use it to solve linear equations. There are different ways. We are picking it one after the other. Exactly. So you can use other methods
All
to
right.
solve if you
Yes, ma'am.
want. Okay. So we have the real line.
Okay, thank you.
We have the real line, which is a horizontal line, and it's starting from minus infinity to plus infinity. 0 at the middle. We have it's in there. Now, so let A, B, and C be real numbers. We write A less than B. A is less than B. If B minus A is a positive number, A is less than or equal to B if A is less than B or A is equal to B. If A is less than or equal to B and B is less than or equal to C, it implies that C is also less than or equal to A is also less than or equal to C. That's the transitivity law. A is less than or equal to B. B is less than or equal to C. Implies that A must be less than or equal to C. So we have the interval on the real line. How do we read up the real line? So the first one there says x in arrow. The element x in arrow is read as x such that x is strictly less than A and is strictly less than B. This is what we call our open interval. When we say X is strictly less than B and strictly greater than A, our A is strictly less than X, and X is also strictly less than B. It means that the element is on the open interval. X is not equal to A. When X is equal to A, the interval will be what? Closed. Since it is strictly less, it will be open on the side of A. And yeah, if it says X is strictly greater than A, it will be open on the side of A. And strictly less than B, it will also be open on the side of B. So yeah, we call it what? The open interval. For the second one, X in arrow, such that
I have a question.
it's just hold on. X is less than or equal to, X is greater than or equal to A, but strictly less than B. X is greater than or equal to A, but strictly less than B. X being greater than or equal to A, we have a closed interval on the side of A. It is closed on A and open on B. Yes. What is your question?
What do you mean by being open and being closed?
What's an opening?
I don't know.
What's a closed interval? The closed interval.
This when
If you have an interval,
circle being
just listen.
shaded.
Just listen. If you have an interval, X lying between, I'm giving an example, X lying between 1 and 2. X is greater than or equal to 1, and the same X is less than or equal to 2. When it's greater than or equal to 1, it means that it is closed. It is closed at the side of 1, and it's less than or equal to, it is also closed on the side of 2. And this implies that 1 and 2 are members or are elements inside that interval. Now, the first one we looked at said A is strictly less than X, and X is strictly less than B. That's what the first one says. When it is strictly less than, it means that it is open. It's open on A, and it's also open on B. And what does this imply? If maybe they list out all the elements inside that interval AB, all the elements, let's say the element lies between 1 and 10 inside the interval AB. Now, since it is open on A and it's open on B, then I tell you, okay, what are those elements that are directly inside that interval, that are not on the edge? It's open on A, it's open on B. What are the elements inside that interval?
2 to 9.
2 to 9. Why do you say 2 to 9?
Because it's less than 1 and
Because it's strictly less than.
no. Okay.
But ma'am, it should be from minus infinity to 9.
Minus. Where do you see minus infinity?
So, ma,
Strictly less than.
does that mean
Hold on, one by one.
Less than 9.
I can't take everything at once. Yeah? Who is talking? I'm hearing you.
Ma'am, you said strictly less than 1 and strictly
Mm-hmm.
less than 10, right? So now it should start from minus infinity, because less than 1 is like number from 0, -1, -2 to infinity,
I said
negative
strictly
infinity.
less than 1. That
Relax,
means
Kola.
1 is
Yes,
the
ma'am.
one at the edge. It does not exceed that 1. So it will be open on 1.
Is it less than and equals to, or just less than?
The one I use 1 and 2 to represent. I said less than or equal to. Less than or equal to.
Ma, can
So
you continue,
to
ma?
be
We
the
will
closed
understand in the
interval.
course of the lesson.
That's the closed interval. So the one I use A and B, I used open interval. So the next one, the third one says x in R such that A is strictly less than x. That means it is open at A. And x is less than or equal to B. It is closed on B. So we have it there. X in R such that x is less than or equal to x. A is less than or equal to x, which is less than or equal to B. It is closed on both sides. X in R such that x is greater than A. X is greater than A. That means it is open on A and it is also open because you don't know the extent of the greatness. Exactly, it is greater than A, means it can tend to infinity, but it does not what exceed that A. A is the bound. Exactly. Okay. X in R such that X is greater than or equal to A. Yeah, it is closed on A because it's greater than or equal to. A is inclusive, it's closed there, and it tends towards infinity. X in arrow such that X is infinity and open on B. X in arrow such that X is less than or equal to B. So we have it being closed. It's less than or equal to B, closed on B and open on the other side. Arrow, which elements in arrow runs from what? Minus infinity to infinity. Are we good? And
Sorry,
so
ma'am. Can I ask a question?
yeah.
So now, we're talking about strictly, and I see whenever you mention this strictly, you won't have infinity in the answer. But whenever
Can't hear
it's like x is less than just one element, like x is less than b, you're putting infinity.
Is it which of the ones are you asking?
Like, can you go back to the question? Like, so now the first one there, from the first one, second one, and the third one there, with the first one, they have no infinity there because you mentioned strictly. Because
no,
x
because I
is
mentioned strictly. Because I have A and B. The range we are looking at is between A and B. That's the range.
Okay. Okay, whenever it is just between just one range, we are not using, we are using
We are
infinity.
looking at the element of x. X is any possible element within the range of A and B.
Okay, then, thank you.
You get it?
Yes, ma'am.
Okay.
Thank you.
So let's continue. So the absolute value of a real number.
Ma, I have a question.
Yeah.
So that means a closed interval is one in which the values of A and B are also present in whatever values are going to be found in X.
Yes, when they are equal. When they are less or equal. When you see that less or equal sign, the interval is closed. It implies that A and B Once that less or equal to sign is on both sides, it implies that those values of A and B, they are inclusive. Is that clear?
Yes, ma. Thank you, ma.
Okay. So the absolute values and equations. The absolute value of a real number, A, is the number A, or is given by the number A if A is greater than or equal to 0, minus A if A is strictly less than 0. If we are given any number A in R, the
Sorry, ma'am.
absolute value of A, let me finish, is equal to the absolute value of minus A, which must be greater or equal to what? 0. Normally, we say absolute values are always positive. Yes?
Okay, I wanted to say that the absolute value, that minus A, if A, you wrote less than 0, is it less than or strictly less than 0?
Yeah.
Yes,
Minus
there.
A. If A is strictly less than 0, that is there. Huh? Any
Sorry, ma.
problem
What's
with this?
between just less than and strictly less than?
No, what I'm saying
Of
is you
course,
wrote less than, and you are saying strictly less than. Like, which one are we to follow? Is it the one you wrote or the one you are saying?
the absolute value of a real number. Normally, when we have absolute value, we say absolute value is always positive. Is it not?
Yeah.
Now, A, if A is greater than, is A when it's greater than or equal to 0, we have A. Now, the absolute value of minus A, if A is less than 0, that's what I wrote there. Now, when the absolute value is less than 0, that means we say that value does not what? Exist. Because absolute value is always positive. As we move forward, you will see in the example I will give, you will be clear with what is up. So just give me some time. So we should note that given A in R, the absolute value of A equal to minus A equal to the absolute value of minus A whenever we have it greater than or equal to 0. The distance between any 2 points A and B on the real line is given by the absolute value of A minus B, or B minus A, as the case may be, given algebraic expressions S on a real number K. If K is greater than 0, we have the absolute value of X to be equal to K. If K is equal to 0, the absolute value of X is equivalent to 0, is equal to 0. If K is less than 0, the absolute value of S equal to K is not possible. Okay, let's look at the example. Solve the following. The absolute value of 2x minus 5 equal to 3. Remember, in this example, our absolute value is equal of 2x minus 5 is equal to a positive number 3. So we have 2x minus 5 equal to 3, or 2x minus 5 equal to minus 3. At this stage, absolute value of 2x minus 5 equal to 3, when it's greater than 0, we have two possibilities. Our x is minus k or k. That's why we have 2x minus 5 equal to 3, or 2x minus 5 equal to what? Minus 3. Our 2x will be equal to 8, or 2x equal to 1. H will be equal to 4 or 1. The next one, when k equal to 0, we have absolute value of 1 minus 4x equal to 0, which gives us as x equal to 1 over 4. We have a definite answer. Yeah. Then the last, when k is less than 0, absolute value of 3x minus 5 equal to minus 2. This is not possible because our absolute value cannot be negative. Am I good?
Yes,
Can we
ma'am.
continue?
Yes, ma'am.
Yeah.
Okay, let's continue.
Sorry, ma'am, please can you explain that summary?
So we have summary.
Sorry, ma,
Okay.
can you explain the summary?
Okay, I will explain. If c is less than 0, we have ax plus b equal to c. It's the same thing we did. If the absolute value is less than 0, it does not have a solution. If it is equal to 0, it has just one solution.
Sorry, are you going to send the slide?
Please let me finish. If c is greater than 0, then it has two solutions, which we did there. That's the summary. I will send you the slide if you want. But do you have your textbook now? Don't you have FSC textbook?
We don't have communities.
We
We
don't
don't
have
have
it.
it.
We want to
We have
get. We're
it.
just
Okay,
saying we are
okay,
trying to
okay,
get.
okay.
We don't have any textbook.
Please just send this slide.
We are relying on the slides, ma'am.
I will send it.
Yeah,
Properties of
thank you, ma'am.
inequalities. We have addition properties. We have multiplication properties. So addition property says if A is less than B, then A plus B must be less than B plus C. If A is less than B, then A plus B must be less than B plus C. Multiplication property. If A is strictly less than B, then we can have AC being strictly less than BC if C is greater than 0, AC being strictly greater than BC if C is less than 0. Similarly, we can use the less than or equal to, greater than, and greater than or equal to properties. Let's look at some examples. Okay. Solve minus 3x minus 5 greater than 12. We have minus 3x. Minus 5 will go over to the other side. The negative sign will become positive. So we have minus 3x being greater than 12 plus 5. Minus 3x being greater than 17. So we have x will now be less than, once minus, we divide through. We have the sign will change. So we have x being less than minus 17 over 3. So our x now will be in what? Remember, x is less than 17 over 3. X is strictly less. We are trying to use open and closed intervals now. X is strictly less than less than minus 17 over 3. Since it is strictly less, it will be open at B. It is less. That means the other side will go towards minus infinity. Is it clear? X will lie in that interval.
It is clear.
Yeah. So the next one, we have minus 2x plus 1 less than or equal to 3 over 2 minus 5x. We have minus 2x plus 1 less than or equal to 3 over 2 minus 5x minus 2x plus 5x being less than or equal to 3/2 minus 1. Is it clear? Once they move, their signs will change. So we have minus 2x plus 5x will give you 3x. And 3/2 minus 1 will give you 1/2. So our x will be what? Strictly less than, if we divide we divide both sides by 3, we'll have it to be less than or equal to 1/6. Now, it is less than or equal to. That means it is closed on what? 1/6. It is closed on 1/6 and open in what? Minus infinity. Is it clear?
Yes, ma.
Yes, ma, it is clear.
Okay. For the third example, I have minus 2 less than or equal to 5
Sorry,
over
ma.
3 minus 3x, which is less than 5.
Ma,
Yeah.
you said it was closed for number 2. It's closed on the left side and is equal to 1/6 on the right side.
It is closed on 1/6. The solution says x is less than or equal to 1/6. It does not exceed it. Once you see that less or equal, there are two possibilities. Less or equal, that means it does not exceed the 1/6. It is closed on 1/6. Then the
Okay.
less,
Um,
you get it?
ma'am.
The less
Yes.
part.
Then what of
Sorry,
the
ma'am.
less? The one in question 1.
It's strictly
Ma'am,
less.
for the
That's why I
question
put
one,
open there. You see that the
Oh,
interval
are we
that is
meant
there
to
is
put the
different.
minus 17/3?
okay.
It's the interval that dictates what is there. Look at it. The interval there is an
Oh,
open interval. Look at the interval on the other side. It's closed.
yes, ma.
Are you good?
Yes, ma'am.
Okay.
For the
Yeah, good,
number
ma.
one, it really says less than and not equals. So are we meant to put that minus 17/3? I know it is going to minus infinity, but since it is less than, are we now meant to put the minus 17/3 there?
Okay, list. Look at it. If I say A is less than or equals X is less than or is less than, strictly less than B. Would you put B there? There's something that's confusing you. Once I put this minus 17/3 and I put an open interval, if I want to interpret it, are you with me? If I'm
Yes,
interpreting
following.
it, maybe and say, okay, list out all the possible elements that should be in this range. Of course, there will be elements, yeah, but this minus 17/3 will not be inclusive. That is
Okay.
why the interval is open.
All right,
Since
ma'am.
I've opened the interval there, I'm telling you that minus 17/3 is not inclusive, but any other number just before that minus 17/3 is part of it.
Okay.
You get me?
Yes, ma'am.
But once the interval is closed, that number is inclusive.
All right, ma'am.
I'm not sure if we can finish this our class today. Oh no. All right, let's continue. So I have the third example, minus 2, which is less than or equal to 5/3 minus 3x, strictly less than 5. So we'll do arithmetic. After that, we have minus 10/9, strictly less than x, which is less than or equal to 11/9. you see that S is greater than minus 10 over 9. Abi? Or minus 10 over 9 is strictly less than X. So the interval on that side is what? Open. But when X is less or equal to 11 over 9, the interval is what? Closed. Are you okay?
Yes,
And
ma'am.
this, are you okay?
Please come again.
Ah,
Please come again. Please
Ah,
come again. I don't understand.
I said for S less than or equal to 11 over 9, the interval is closed on
it's
11
first.
over 9 and is open on minus 10 over 9 because
Okay.
X is strictly greater or minus 10 over 9 is strictly less than what? X.
Okay, I understand better now. So that means because it's appearing, that means it is not an exception and it can appear even if it is infinite, even if the
I didn't
less
get your
than or
question.
equal to. I said, so I understand better now because for the fact that it's showing in the bracket there, that means it is not an exception, even if it can be infinite.
No, it's not. It can show on the bracket, not that it's not showing on the bracket. But this bracket on its own has an interpretation. When somebody sees
Okay.
it like this, there's an interpretation attached to it. That is what I'm trying to explain to you. That this bracket on its own is telling you that. It's telling you that 11 over 9 is a member of the elements inside this set.
Yeah.
But minus
That's what I'm
10
trying to say,
over
but I don't
9.
know how to put it well.
Because why is it there? Why is it inclusive? This 11 over 9? Because the
I
interval
can't
is
see it.
closed here. And
Yeah.
this is not
Sorry.
inclusive because it is open here.
Get, uh, hello, ma.
Yeah.
please, is it too much?
Hello,
We
ma.
have a class.
My class is 2 hours.
Hello, ma.
Ah,
Yeah. My class is 2 hours.
Ma'am, let's
So let's
continue.
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 And I say you
Sorry,
An
ma'am, I want to ask a
algebraic
question, ma'am.
expression.
please, I have a question.
Let's continue. Inequalities with absolute values. For an algebraic expression x and a real number k greater than 0, we have the absolute value of x less than k to be equivalent to x line between minus k and k. And the absolute value of s greater than k is equivalent to s less than minus k or s greater than k. Similar properties applies to less than or equal to or greater than or equal to sign. So we have examples there. We have this first example where we have absolute value of 5 minus 2x being less than 1. So we have 5 minus 2x being less than 1. It lies between 1 and minus 1. So we have minus 2x solving. We are trying to solve this now. Minus 2x will lie between minus 1 minus 5, minus 1 minus 5, which is minus 2x lying between minus 6 and minus 4. And solving further, we have x lying between 2 and 3. S is less than 3 and greater than 2. So S is in the interval 2,
fudge.
comma 3. Similarly, we do for the next one. So
Please, I have a
let's
question.
write it as
Question.
Please can you go back to the other slide?
The principal square root of a real number a, denoted by square root of a, is what we call the non-negative real number that when multiplied by itself equals a. We have the radical, the radicand, which is 25, and everything we call it the radical expression. If we have x to be equal to square root of a, if x is greater than or equal to 0, and we have x squared to be equal to a, we note that the square root of a exists as a real number if and only if a is greater than or equal to 0. We cannot find the square root of a negative number. Of course, it will drive you to complex kidding. So we can only find or determine the square root of a real number. Okay, if we are given a to be greater than or equal to 0, it implies that the square root of a squared will give us a for any real number a. The square root of a squared will be equal to the absolute value of a. We should compute. I have square root of 25, which is 5. Since
sorry, I don't understand.
What is there you don't know? What do you don't know? What's your problem? Just indicate it. Talk now. What's your problem there?
Like I don't understand one.
That's principal problem.
Sorry.
Square root. You don't understand square root.
Okay.
And you are in the university.
Don't ask the question.
Some people they thank them to just come and be.
Go back
Don't
to your
ask the question.
Okay.
But the thing is,
Not
I
ask the question.
feel.
What is your problem? So our time is going. I want to cover up.
But these radicals, man, do you want me for radicals?
The square root sign is the radical. The radicand is the number inside. Then the radical equation is everything. I'm only trying to explain each of the symbols there for you. Square root of 25 is equal to 5. Since 5 squared is 25, we have square root of 169. 25 plus 144, which is square root of 169 equal to 13. Since our 13 square is 169, square root of 18, square root of the root of 81. This will give you square root of 9, which is 3. And 9 squared is 81, and 3 squared is 9. So, if we are given simplifying square roots using some of these properties, if you are given AB elements greater than or equal to 0, we have square root of AB to be equal to square root of A times square root of B. We have square root of A over B to be equal to square root of A over square root of B, such that our B is not equal to 0. How to simplify radical expression? The person that don't understand, listen very well. Factor any perfect square from the radicand. Write logical expressions such as products, quotients of radical expressions. So then you simplify. Let's look at this example. If xy is greater than 0, let's simplify the square root of 81 x to the power 4, y to the power 4 times 2x. So we have 81. What's square root of 81? Of course, it's 9. Square root of x to the power 4 will be what? X squared. Square root of y to the power 4 is what? Y squared. Times what? Root of 2x.
Root of 2x.
Let's look at the other example. We have 234 x to the power 11y. So we have the square root of 234. What is it?
Combine it. It's in decimal 15.3. 15.297 actually.
Can we break it down? We can break it down. Yeah. Let's look at 234 x to the power 11y over this. What we have here, square root of 234 x to the power 11y over square root of 26 x to the power 7y is the same thing as square root of 234 x to the power 11y over 26 x to the power 7y. Now, if you use the properties of indices, you are going to have
Suggestion.
this
Subtraction of the powers.
subtraction of the powers. Please hold on. Hold on. You are going to have, if you use the properties of indices, you are going to have the division and subtraction of the powers. So our y will go off and our x will be 11 minus 11 to power x to power 11 minus 7, which will give us 4x. Then our 234 will divide what? 26 will divide what? 234, which will give us what? 9.
9.
Yeah. To give us 9. So now take the square root of 9x to power 4. We have 3x squared. Can we continue?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
So now we are looking at nth root.
Yes, ma'am.
Let n be in n be such that n is greater than or equal to 2. Okay? So we want to look at nth root. We have looked at normal square roots and the rest. So the principal nth root of a real number a, written as the nth root of a, is a number with the same sign as a when raised to the nth power. X equal to square root of a to the power n. If x is of the same sign as a, x to the power n equal to a. N is called the index. Now let's look at the example. We have square root of minus 32 raised to power of what? 5. As we are looking at the fifth root of this, raised to power of 5 equal to minus 2. Since minus 2 to power 5 is equal to minus 32. We have this to be equal to 2. Since minus 2 to power 5 is equal to 32. And we have the fourth root of 81 equal to 3. Since we have 3, just order 3 times 3 times 3. 1, 2. Okay, 81. Since we have 3 to power 4 to be equal to 81, the nth principal root only exists as a real number for any n greater than or equal to 0 if x is greater than or equal to 0. For any x in arrow if n is odd. So it can only exist for numbers n greater than or equal to 0, and also if n is odd. Yes, what is it? Somebody was talking. Can I continue?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, ma, yes,
Yes,
you can
ma'am.
continue,
Yes,
ma.
ma'am.
Yes,
Yes,
ma'am.
ma'am.
So
Huh?
if we have the nth root of A and the nth root of B to be real numbers, then nth root of A times the nth root of B is equal to the nth root of AB. Nth root of
I
A
have a question, ma'am.
divided by the nth root of B is equal to the nth root of A over B if B is not equal to 0. Then we have these other properties too. What's your question?
For when you said nth root of A and nth root of B make nth root of AB, does the root have to be the same or different?
The same.
So let's say 5 roots 32 and 5
Fifth
roots
root.
60 something. Hmm?
Yeah. Yeah, the n has to be the same. The n. Can we continue?
Yes, ma'am.
So we have solving radical equations now. A radical equation is an expression in which variables appear in one or more radicals. Now, if we have,
Sorry,
this
are
is the
these
third
normal
root of
marks?
2x minus 4 minus 2 equal to 0. We have to solve this radical equation. This is the third root of 2x minus 4 equal to 2. Of course, the root is not affecting this 2. That's why you can cross it over. And once you cross the equality sign, the sign changes. So we have, if I take the cube roots of both sides, or the cube of both sides, if I take the cube of both sides, this will cancel. If I take the cube of both sides, this cube roots will go off, and we'll have 2 to the power 3. So we have 2x minus 4 to be equal to 8. Our 2x equal to 12. Our x is equal to 6.
Ma'am,
So how we solve it? Eh?
is this the reason why we're getting an answer? Is it because it's equal to 0, or it's just a normal solving of the equation?
Of course, you have an answer. Look at the equation itself. If you solve it,
Yeah,
you have an answer.
direct solving, or we're getting one answer because it's like the absolute value thing here. If it's less than 0, you get no solution. If it's equal to
There's
0,
no absolute value here.
okay, thank you.
So let's deal with polynomials. A polynomial. So a polynomial is an expression that can be written in the form an xn to a1 x1 plus a naught, where our ai's are the coefficients, our ai xi are each of the terms, our a naught is a constant, our n is the degree, n is the degree of the polynomial, an is the leading coefficient, an xn is the leading term, which is our first term. Okay, so what we want to do is how we can solve all these polynomial equations, because they make use of what? Real numbers too. So specify the degree, leading coefficients, and leading term of the two following polynomials. We have, they're only asking you a question here, that you should specify the degree, the leading coefficients, and leading term. Specify the degree, the leading coefficients, and leading term of the two following polynomials. We have 8x cubed plus 2x squared minus 4x plus 2. 8x cubed plus 2x squared minus 4x plus 2. And we also have, for the second question, minus 4x plus x minus x to power 4 plus x squared plus 5x. Now, for the first polynomial, what is the leading coefficient?
3.
8. 8 is the leading coefficient.
It's the leading coefficient.
What is the leading term?
The leading
X cubed.
term
8x
is
cubed.
x raised to power 3.
8x cubed. And what is the degree of the polynomial equation?
The third degree.
3.
3.
3.
Why is it 3?
Highest power is
Because the greatest power there is 3.
The highest power there is 3.
Oh.
You have the polynomial with the highest degree, which is 3. Okay. We have adding and subtracting polynomials. We combine like terms, specify, simplify, and write in standard forms. So we have that same polynomial, 8x cubed plus 2x squared minus 4x plus 2. We want to add it to minus x to power 4 plus x squared plus 5x. How do we add it? We add polynomials of same power, of the same term. So the one with the highest power is minus x to power 4 plus x to power 3 plus 2x squared plus x squared minus 4x plus 5x plus 2. We combine like terms. You add like terms together, then you simplify.
Ma, I have a question, ma.
Ask your question. Ask your question.
In the last slide,
Let us
that
finish before you ask the
minus x
question.
raised to power 4. Yeah. So what's the leading term?
I asked you that question before. What is the leading term?
Minus 1.
Because I thought
Matu, she
might
stopped
not be
crossing you. Man, she like finish before they ask any question. But like we're getting what we're saying now. It's asking questions. We can't even understand them. We have to go back again.
Yes, ma.
Yeah. The leading term from the explanation of, we gave a polynomial f of x equal to an xn plus a up to a1 x plus a naught. Okay. We have a leading term which we defined as an xn. It implies that the leading term, of course, we carry the expression with what? The highest power. It will carry it with the highest power. So for that example, minus x to power 4 plus x squared plus 5x, the leading term will be minus 1 x to power 4. Are you okay?
Yes, ma.
Yes, ma.
Who
Yes,
asked the
ma.
question? Can we proceed now? Are you okay?
Yes, ma. You can proceed.
Okay.
Excuse me, ma.
So, yes.
Science students have another class now.
I'm supposed to stop by 4. So any person that is growing, you are growing at your own rates. When it's 4, I will stop. Okay.
But man, the thing is, we don't even know the course we are offering. That's why we're just joining all the link they sent to us.
This is a general course. It's a faculty course. Almost all the university offer this course. So,
MTH 101.
so we have looked at addition and subtraction of polynomials. Now we are going to multiplication of polynomials. Multiply. How do we multiply any two given polynomial? You multiply each term of the first polynomial by each term of the second using distributivity. You combine like terms, then you simplify. That's the procedure you follow. Now, let's look at the example. We have 2x squared minus 4 minus x to the power 4 plus x squared plus 5x. We want to multiply those two polynomials. So you have 2x squared multiplying this second polynomial and minus 4 also multiplying the second polynomial. So after using 2x squared to multiply minus x to the power 4 plus x squared plus 5x, use minus 4 to multiply that same polynomial. Then you simplify. We will get the polynomial minus 2x to the power 6 plus 6x to the power 4 plus 10x to the power 3 minus 4x squared minus 20x. You can still try this other one here. There's an exercise here which you can try on your own. Using binomial theorem, we have using 4 to multiply binomials. Okay, so 4, what does it mean? We have the first term, the outer term, the inner term, the last term of each binomial. So if we have two expressions, ax plus b, cx plus d, we want to multiply as we have the first term, ax multiplying cx square, cx plus ax multiplying d plus b multiplying cx plus b multiplying d. So after that, you select like terms and bring that's what is common in between. So we have examples. We have x plus 2 multiplying 2x minus 7. We have 2x squared minus 3x minus 14. The second example is done similarly. So we look at special products. When a binomial is squared, the result is called a perfect square. When you square a binomial, what's a binomial? And I asked the question, what's a binomial?
Binomial is
The
like
binomial is
equation that is always like the highest number is 2 or something like that.
The highest power, possible
the
power is
highest power.
2.
The highest power.
Okay. So when you get at the equation, the highest power is 2 is a binomial. Then a monomial is of degree 1, the highest power is 1. Then you have a trinomial, then you have polynomials, which are of higher powers, depending on what you're looking at. Okay, so when a binomial is squared, the result is called a perfect square trinomial. We have a plus b square to give us what? A square plus 2ab plus b square. A minus b will give us a square minus 2ab plus b square. So we have difference of square, a plus b and a minus b to give you a square minus b square. We can try the following exercise. Check it out in the following exercise given there. So we'll look at factorizing using special products. How do we factorize using special products? The first step is to factor perfect square polynomials. Confirm that the first and last term are perfect square. You look at the first and last term. They are perfect square. The middle term is plus or minus 2ab. Then write a plus or minus b all square. To factor the difference of square, we confirm that the first and last term are perfect square with opposite signs. There's no middle term. Then we write this. A minus b into b, a plus b. Factorize the following. So we can factorize the following. Special products, sums of cubes. We have sums of cubes, difference of cubes. We have an example, factor the following. S cubed plus 64 equal to, what's the how would I call it now? X cubed. If we want to change 64 to be 4 times 4 times what? 4. 4 times 4, 16. 16 times 4 should give us 64. So, which is the same thing as S cubed plus 4 cubed. And this is the same thing as S plus 4 into x squared minus 4x plus 4 squared.
Sorry, ma, please, can you explain this SOAP?
Same opposite, always positive. What we remember SOAP, we are using this to look at the signs. You understand? I think to look at the signs when expanding. If you have like difference of cubes now, you have same opposite. You always have it as what? Positive. I don't know. There's a place there. We have what? We have x cubed minus b cubed. If we have it x minus 1 and x plus 1, we have it x minus 1. So if we have same opposites, always same opposite, always positive. If the signs are saying, I think we always have a positive sign. That's what they are saying. Same opposite, always positive. Okay. So we have factoring a trinomial with leading coefficients 1. We have a trinomial x squared plus bx plus c can be written as s plus p, s plus q, where pq equal to c and p plus q equal to b. List factors of c. Find pq, a pair of factors of c, such that our pq equal to b. Then we write x plus p, s plus q. us to be able to factor a given this directly. We list out the factors. Then factorization by grouping. If we have x squared, as squared plus bs plus c, we want to do our factorization by grouping. The first thing is to list factors of AC. You list the factors of AC. You find PQ, a pair of factors of AC, such that P plus Q equal to P. I have AX squared plus BX plus C, and I want to factorize. I'm going to check the factors of AC. Then find P, Q, a pair of factors AC such that our P plus Q equals to B. Then rewrite original expressions of this. Let's look at the example. Put out the GCD of this and this, then factor. Let's check the example down there. I have 3x squared minus 2x minus 8. Okay, so we check out the factors of what? We check out the factors such that if we replace it with this, if we replace it with this 2x, if we add any two factor we can determine, and replace it with this 2x, it will give us back this are 2x. And if we multiply, we have 8. So what are the factors? We have...
Please, can you quickly explain the previous slide?
-6 and 4.
Let me finish this one up there. When I'm done, then I'll go back. We have 3x squared minus 2x minus 8. So this will give us 3x squared minus 6x plus 4. And 6x plus 4 is the same as what? Minus 2. Am I right?
Yes, ma'am.
Am I correct? Okay.
Yes, ma'am.
Minus 8.
Yes,
So
yes, ma'am.
I will now factorize. So I will have 3x into x plus 2. And we have 4x into what? X minus 2. 3x is common here into x minus 2. Then I have 4x being common. No, just 4. I have 4 being common. Just 4 into x minus 2. So this will give us 3x plus 4 and x minus 2. So we have proven that we have factorized. Yeah, what are you saying that you don't understand the previous slide? I'm in the previous.
The previous slide.
I'm there now.
But not this one.
Don't pull me back. The time is
sorry.
good.
I'm sorry.
Factorizing by grouping.
So it's not that one.
Is it here?
No, ma. Ma, please go up. Sorry. Ma, sorry, ma.
I can't go back. Do you know what? Do you know my office?
No, we haven't even got to this place.
Do you know my office? The person talking.
No, ma. No, ma.
Are you in Lagos?
Yes, ma.
Maybe you should come to the school and check me in my office if you have any problem. I will explain to you.
Okay, ma, what if you send the slide? Like, after the class, ma, you can send the slide?
Yes, I will.
Okay, thank you, ma.
Okay, so let's continue. Polynomials of several variables. A polynomial may contain several variables. The degree of a polynomial of several variables is the highest sum of the exponents of the variables in a term. You know what several variables? That's when you have more than one variable. You understand? For instance, if we have 2x squared y minus x plus 5y, is an example of a polynomial of two variables. The degree will be the highest power of the sum of powers in each term. So the degree of this particular polynomial is 3. The same rules apply when working with polynomials of several variables as with polynomials of one variable. Expand this. Yes.
Now, please, can you explain that degree again? Like, I don't really get it.
The degree of a polynomial is the highest power of that polynomial. For instance, if I have x to the power 5 plus 2x plus 1, the degree of that polynomial, x to the power 5 plus 2x plus 1, is 5. Exactly. Now, looking at this is a polynomial with two variables, not just one variable. This is two variables. 2x squared y minus x plus 5y. Now, what we are saying here is, for you to get the degree of this polynomial, is for you to add up their powers of each term. The one with the highest will give you the degree. Now, if we look at 2x squared plus 1, the power of that term is 3. The power of minus x is 1, and the power of minus y is 1. So the degree of the polynomial 2x squared y minus x plus 5x is 3. Is that clear?
Yes, ma'am.
The same rule applies when working with polynomials of several variables as with polynomials with one variable. So we have that if we factor it out, by the time you expand, you have this. Rational expressions. We say rational expression is the quotient of two polynomial expressions. We have x cubed plus 1 over 3x squared. That's an example. And we also have x cubed minus 3x plus 1 over 2x plus 5. To simplify rational expression, we factor the numerator and denominator, then cancel out the common factors. To add, subtract, multiply, or divide two rational expressions, apply the same rules to operations on fractions. Now, let's look at the question. We have 9x. Let's look at this example. 9x squared plus 6x minus 3 over 9x squared minus 9. We first of all, we factor it out, then simplify them. Cancel those things that are cancelled. 9x squared plus 6x minus 3. What is common? 3 is common. 3 comes out. We have 3x squared plus 2x minus 1. On the numerator, on the denominator, 9 is common. So we have 9 into x squared minus 1. You can also factor the quadratic equation on the numerator, 3x squared plus 2x minus 1. Just look for the factors, then factorize it out. We'll have, they've used 3 to cancel 9, so that 3 up on the numerator has run off. So we have 3 down on the denominator. Factoring the quadratic equation, you have 3x minus 1 and x plus 1. And factoring the denominator, x squared minus 1. We have x minus 1 and x plus 1. So x plus 1 goes with x plus 1. We have 3x minus 1 over 3 into x minus 1. So we have simplified our expression. You can check out the other examples. You can check out the other examples. You can also check out the other examples. So we are in the process of removing radicals. Removing radicals from the denominator of fractions. And that process is called rationalization. We are rationalizing the denominator. Rationalization.
Will you send the...
Will I do what?
Ma, don't worry, continue, ma.
Guys,
Continue, ma.
Rationalization. So, for a denominator with a single term, we multiply by the denominator itself, which is what we have there. For a denominator as sum or difference of a rational and irrational term, we multiply by its conjugates, which is what we have there. We have an example. If we write in simplest form, 2 over 3 plus root 5 and 2 over 3 root 3 over 10. Let's solve the first example. We have 2 over 3 plus root 5. Rationalize with the denominator 3 plus root 5. We'll have 6 minus 2 root 5 over 4. Using real numbers on exponents. On exponents. Please, I have just 5 minutes more. I have to be fast.
Can you please scroll up?
Guys, shut up now. Shut up. I mean, she teach.
It turns out that
Ma, please continue.
Just take notes that you are in the class. Please don't use foul language. Please, if you have any question, you can ask. It's not convenient for you, fine. You are not in school yet, but very soon you'll be
Ma,
around.
can you please scroll down a bit?
Just hold on. When I'm done, we'll ask.
Okay, ma.
When I'm done, we'll ask all the questions we want to ask. Exactly. Just note your questions. Once I'm done, because of the time, then we'll ask all our questions. It turns out that there's a real number of the form AX, where A is not equal to 0 x in R, such that the following laws are satisfied. We have these two, which we call our exponents laws. If A to the power 0 equal to 1, A to the power 0 equal to 1, if and only if A is not equal to 0. That's the first law. And we call it the zero exponents law. A to the power minus x is equal to 1 over A to the power x, if and only if A is not equal to 0. The negative exponents law. A to the power x a to the power y is same thing as a to the power x plus y. That's the product rule. A to the power x over a to the power y is equal to a to the power x minus y, which is our quotient rule. A to the power x, open and close brackets, y is equal to a to the power xy, our power rule. A to the power ab to the power x equal to a to the power x, b to the power x. Same thing with that of the power of a quotient. So look at logarithm. That's for exponents. Look at logarithm. If x is greater than 0 and b is greater than 0, and we have it such that our b is not equal to 1, the logarithm in base b of x is the exponent of which must be raised to get s. Y equal to log b, log in base b of s is equivalent to b to power y, which is equivalent to b to power y, which is equal to what? X. We have the laws. We have the laws there, and we have some examples which you can also look at. We have the laws, and we have the examples which we can look at. So we look at our natural and common logarithms. We have logarithms in base 10, in base e. So our logarithm in base 10 is common logarithm that we have it in base 2 and so on. So we have some rules which we can use to solve all these logarithm equations. And these rules use rules of exponents and the one-to-one property of exponential functions. We have an example there. It says solve 3 to the power 2x minus 7 equal to 3 to the power 4x over 3. How do we solve it? We have to use the laws of the exponents. Some of those laws we stated above, laws of exponents and logarithm, to be able to solve this. It is solved here, so you go through it. Solved there. You go through the examples.
Ma, your time is up.
So we have
This one.
laws of logarithm. Laws of logarithm. The laws we have already stated above. Okay.
You're just skipping these hard ones.
We stated the laws above. So we
Yeah.
use the laws which we've stated above to solve some of these examples. We say 2 ln x minus 1 plus 3 equals to 5. And we have the second example too. 2 ln x minus 1 equal to 2. And ln x minus 1 equal to ln x minus 1 equal to e, x e plus 1. We also check the second example. Yeah. Then the next is change of base. We look at change of base and the example there. So that's that for real numbers. So far, we have looked at real numbers, how we can represent them, what the operations we can use on them, the operations of addition, of multiplication, of subtraction, of division, using exponents, using them on polynomials, using them on logarithm functions, using them on normal mathematical expressions. We use real numbers there. We can also have some laws which the real numbers satisfy, the laws of commutativity, the closure law, the distributive law, the inverse law, the associative law, and so on. All these we must know. So what you will do now is to go back. I will send this slide to something so that you can post it on your platform. So when you have the slide, you will go back and study everything on it,
Ma, I
one
want to clarify on
after
something.
the other. Yeah,
I want to clarify.
I'm hearing you.
So, about the open and closed interval. So, may I have a question?
Eh?
I said okay. About the closed and open interval. So, I think someone asked a question about this minus 17/3. That why is it included?
Which 71?
So I
Let's
just
go
want to
back there.
clarify. It is okay.
Let's go back there so that we all see what is happening.
Is after that properties of inequalities.
Right there. Yeah.
No.
Yes, ma'am.
Properties of okay. Yes, this is
This
it.
is the place. Okay.
Yes, this is the place. So it says x is less than minus 17/3.
Yes.
So you said it is opened at minus 17/3 since it's
The sign is showing less than. Yeah, that's what I said.
show that it is open or closed. It is through the brackets. For open, we have a curved bracket. Then for the second question, where it is closed, we have like a straight line bracket. So that's just the difference, I think. So I want to clarify if that's different.
The difference between open and closed is what you are asking, Abby. The difference between open and closed. Once you see the brackets less, strictly less, or strictly greater.
Yes, ma'am.
You know, it is strictly less will be open.
Yes.
Strictly greater is also open.
Also
but
open,
when you see less than or equal, it is closed.
Closed.
Greater than or equal, it is closed.
Closed.
You understand? It
Yes,
is
ma'am.
closed. So that's greater than or equal or less than or equal. That depends on the particular position where it's open or closed. But less than or equal symbol indicates that something being closed. You understand? Then strictly less or strictly open, strictly less or strictly greater implies that it is open.
Fridge. Why?
Okay, I'm actually talking about the brackets. For the II, the one in the middle. So the first one, it says the first bracket is like a curved bracket, which indicates that it is opened at
minus infinity. Remember, the answer says, look at the answer.
It's like bracket.
Just look at the answer. Are you with me?
Yes, ma.
Hello, ma.
Look at the answer. The answer says x less or equal. Less means it is less than 1/6. And or it is equal.
Okay.
You understand? So that less has taken care of it being open at minus infinity. You get it? Because you don't know how less it is. So you go to the barest minimum, except you know how less it is. But they've told you that it is equal to 1/6, so it must be closed there.
Okay.
You get it?
Yes.
Hello, ma. About the
Good
third
afternoon.
one.
Sorry. Good evening, ma.
Hello,
Ma,
ma.
concerning the
The third
inequalities with
example,
absolute
please.
values. Sorry,
The
ma.
third example.
Yes,
Please
ma.
hold
The
on
third
one by
example.
one. So hold on.
The
Let
third
me finish
example,
this
ma.
third example.
Send me the slide after the class.
Okay. This third example says x is less or equal to 11/9. Abi?
Yes, ma.
X is less or equal to 11/9. And S is greater. S
Okay,
is
ma'am.
greater.
Sorry, ma. Sorry to cut you off, ma. So my question now is that you, after getting -2 -5/3, then it's turned to like how did it turn to -11/3? Yeah?
Where is 11/3? Where
Look
did you
at
say?
the solvings. I mean the solvings.
The solving. We have -2.
Yes,
Being
after the
less
minus.
than or equal to 5/3 minus 3x, which is less
No.
than 5.
Yes.
-2 less than 5/3. I'm taking away 5. I'm multiplying both sides, just like I'm doing both sides of equation. So I'm subtracting 5/3 from both sides to take it away from
Okay.
the middle. You understand?
Okay. I understand, ma. Yes, ma. I understand, ma.
So you get it now. Are you okay now?
Yes, ma. Yes, ma.
Yes,
Oh,
ma. Yeah.
sorry, the other time you wanted to say fear your offices.
Sorry. I have a question.
Who is asking question?
Ibu
Yeah.
B. Okay,
Okay.
ma. Yes, ma. I just have one question. The inequalities with absolute values. That's the one
Okay.
I have a question. So, yes, ma. I can just scroll down a little bit. My was just.
It's when I did there. Just let me know.
No. Ma, go up. It was right under that the one that they just asked now. Go up.
Ma, the next class has actually started over here, ma. Can we join the other class, ma?
Go up.
I'm done with my class. I'm just responding to questions.
So which class
Go up.
is on now?
Ma, if we leave the class, can attendance still be taken, ma?
Yes, ma. It's okay. Ma, this is here. It's here.
I can take
Yes.
my attendance. Don't worry.
All right.
Yeah.
So my question is just concerning, like, if is it so like is it a law, or why is it that when the absolute value is less than x is now greater than minus k, and x is less than and x is less than k, while when the absolute value is greater than x is less than minus k, or x is greater than I mean x is greater than k? Is there like a reason why it's or that the second one is or
It's
is it
not
just
a
like
law. This is simple logic. You should be able to see it. They are just playing with numbers here.
Yeah, because
Eh? They are playing with numbers. If you have the absolute value of x being
Yeah.
less than k. Eh? That means
Yes,
k
ma'am.
is greater than this. They are telling you this will be the possibility. X, we have two solutions. And this will give us what? I will see that in one of the examples we solved, where what we have here is less than k. We've seen that, I think we saw it in one of the examples. I don't know where it is, where we have something equal to 3 or so. I don't know. So we have two solutions. Now, when it's greater
Yes, ma'am.
than k,
Yes, ma'am.
when this is greater than k, we say it is equivalent to the absolute value of x being less than this, or the absolute value of s being greater than k. When it is greater than k, we have, when the absolute value of x is greater than k, what does it imply? It implies that our k, they've not told you it is 0, and they've not told you it is negative. But most times when it is greater, you tend to think that the absolute value is what? Negative. Is it not?
Yes, ma'am.
Yeah.
Eh,
If that absolute value they told you is greater than k, sometimes
yes.
you'll be thinking, is it 0? Of course, absolute value is a positive number. You understand?
Yes, ma'am.
Eh?
Yes, ma'am.
Is it positive? Is it 0 or is it a negative number? That's when it will be greater than k. You understand? That's why they put s will be strictly less than minus k, or x will be greater than k. If x is greater than k, we have two possibilities. It is either we have that absolute value to be 0. Eh? And when it is
Yes.
0, it has just one solution. If it is less than 0, it doesn't have a solution.
Wait,
You
ma.
get what I'm saying?
No, ma. No, ma. I don't get. Ma, for the second one, you're saying that the great absolute value of x is greater than k. Then it's equivalent to the x is less than minus k, or x is greater than k. So I also want to understand why it's or.
Why is?
Why it is or. Why
Because
does
there are two possibilities. That's what I said now. If you say absolute value, it is a positive number.
yes, ma.
Or maybe let's say 2. The absolute value of 2, for instance. You say it is greater than k.
Zero. Okay. Greater than
When
k.
can the absolute value of 2 or even 1, let's use 1. 1 is the least, which is 1. When will it be greater than k? That means k will either be 0 or k will be negative. Those are the two possibilities.
My body said k. My body said for an algebraic expression x and a real number k is greater than 0. They didn't say k is supposed to be less than 0.
There are two possibilities when the absolute value is greater than k. It is either k is negative or k. Of course, when k is 0, you have an like you have a solution. K is our solution. You understand?
Yes, ma'am.
K is our solution. The
Yes,
first
ma'am.
one, we say k lies between two solutions. You understand? Whenever
Yes.
the absolute value is less than, we have two possible solutions. Then for this second one, if it is greater, it is either you get 0 or you get a negative absolute value. And once it is, that absolute value is equal to a negative number, then it has no solution. When it is equal to 0, it has just one solution. Don't you get it?
Don't worry, mama. Yes, ma'am. Thank you, ma'am.
Just hold on, hold on. I want to show you something. I pray I should still see it.
No, mine is up. Mine is up.
It's up.
Yes, ma'am. You
That's
look for the absolute value one. Yes, mine is up.
eh?
It's just 3 pages above it.
You put. Oh, thank you.
Yes, ma, go up.
Where is it set now?
Okay, let's look at this now. At this point, our absolute value is less than, no, this absolute value is less than k. 3 is our k. So this one has two solutions, which is what we solve here. That's 2x minus 5. The absolute value of 2x minus 5 is less than k.
Yes, ma. Yes. Yes, ma.
Now, that's our assumption. So, this is equal to 3. 3, of course. So, it has two solutions, which is 4 and 1, which satisfies that first condition that is there. Do you agree with me?
Yes, ma. Yes, ma.
Now, at this point, the absolute value is equal to 0.
Yes. Yes,
And
ma.
at this point, it is minus 2.
Yes, ma.
These are the two possibilities whenever the absolute value is greater than k. When the absolute value is greater than k, the only thing it will give you is what? K is a number. If the absolute value is greater than k, it will either be that it is equal to 0 or it is equal to a negative number.
All right, ma. Yes,
You
ma.
get me?
Yes, ma. Understand.
That's what they are trying to explain there.
Yes, ma. So when c is greater than 0, it has two solutions.
It has,
Like when k is greater than 0, it has two solutions, right?
yes, it has two solutions for the first one. No, the first one says when the absolute value is less than k, it has two solutions. When it's greater, there are two possibilities, not solution. There are two possibilities. The first one is that it must be equal to 0 or less than 0. Two possibilities.
All right, ma.
And for the situation where the absolute value is equal to 0, then we'll have just one solution. When the absolute value is negative, then it will have no solution.
Yes, ma. All right. Thank you, ma.
Do you get it now?
Yes, ma. Yes, ma.
Okay. All
Bye, bye,
right,
ma.
so I can end the class. Thank you, everybody. I will
Thank
send the
you.
slides to you now.
I
So,
want to say a big thank you.
Thank you, ma.
I want to say a big thank you because your classes are very
Thank you, ma.
understandable.
Thank you, ma. God bless you.
thank you very much.
Thank you for the class, ma. Thank you.
Thank you.
God bless you, ma.
Thank you so much, man. Thank you so much, man.
So much, ma.
Thank you so much, ma.
Thank you, ma. We really
Thank
appreciate
you,
it. God
ma.
bless
Thank you
you.
so much, ma. Thank you, ma.
Thank you, everybody.
He has
God bless
gone.
you.
Thank you, ma.
Thank you, ma.
Una
Thank
wicked.
you, ma.
All right,
Please,
bye.
sorry, everybody. We that was shouting, shut up before.
Una won't finish the ma. Thank you, thank you, thank you.
Mona log out. Go sleep.
I beg, wait. I don't
Go
understand
chop
what she
rice.
talk. I don't understand anything. Oh.
Go and read from your
It's
slide,
actually
Jerry.
simple stuff, sha.
Okay,
Wait, my
thank you, ma.
slide already never drop. I never say any slide now.
We might go class already.
And you
And she
go
will
to
drop it to the
Alabama.
sub then.
You know understand, but thank you for your mouth.
The
Okay,
sub then
okay.
will drop it on the group.
All right,
Where is he
thank
going to
you.
stop the fight?
I knew. She know the look out, look out. I'm
Now,
not.
all right.
Left. Jesus.
You to leave.
So okay. Never.
I hope she took attendance. I mean, I cannot come and stay here for nothing.
66.